Hi folks, we're going to take a look at page 85, number 11H. So here we're given this function and we want to find the rate of change at x equals 5. Okay, so this time here I'll use the h approaching 0 formulation. So looking for the slope of the tangent to find the rate of change, and so we're going to take the limit as h approaches 0 of f at a plus h. So in this case here a is equal to 5, so 5 plus h minus f at 5 all over h. Okay, so let's input all our info here. So I'll just replace x by 5 plus h. So we have 8 over square root of 5 plus h plus 11. Okay, and then here minus 8 over square root of 5 plus 11 and all over h. Okay, so let's simplify here. So here I can write 8 over square root of 8 plus 16, and here we've got 11 plus 5, again 16, so square root of 16 is 4, so 8 over 4 is equal to 2. Okay, and all over h. Okay, now here we see a, just going to see if I can make that a little clearer. There, that looks a little better. Okay, so what I'm going to try to do here now is subtract this rational expressions here. So limit as h approaches 0, so it looks like my common denominator is going to be square root of h plus 16. So the 8 won't change, but I will have to multiply 2, or negative 2, by square root of h plus 16. Okay, so here I'm left with the common denominator of h plus 16, and here I might as well realize here that I'm also dividing the whole expression by h, so I can just bring that into the denominator here. Okay, save myself a step, just have to rewrite that. So as we've seen a few times now, we have an expression in the numerator that includes 2 terms, and one of them is a square root. So the way in which we deal with that is to multiply numerator and denominator by the opposite sign here in order to be able to use a difference of squares. So I'm going to multiply by 8 plus 2 times h plus 16. Okay, now you may know this term. That's called multiplying by the conjugate. Okay, so 8 plus 2 times h plus 16. Okay, and hopefully this will allow us to simplify enough to be able to evaluate the limit. So here, this is just a difference of squares, so I'm left with 64 minus, so the square of this term here. So again, in a scenario like this, please make sure that you're squaring this whole expression. So I'm also squaring the 2, so that's going to be 4 times, well, the square of a square root is just whatever's inside, so h plus 16. And in the denominator, I've got this big expression here. Okay, so you're probably starting to notice that solving these questions really does depend on how good your algebra is. Okay, so if you need to take a bit more time to do these, you'll just have to do that. But having said that, if you are confident in your algebra, try to go quickly, as I'm trying to do here. Okay, so here negative 4h and negative 4 times 16 is going to be negative 64. So in the end, I'll have 64 minus 64, and that'll cancel out. So I'll be left in the numerator here with just minus 4h, which is really what I was hoping for. Okay, because that will now cancel out with this h in the denominator. Okay, so I get what I need, because at this point, as h approaches 0, the denominator no longer approaches 0. Okay, so as h approaches 0, the numerator will just remain, let me write it out here, square root of h plus 16, and then we'll evaluate. Okay, so as I was saying, as h approaches 0, the numerator always remains negative 4, and the denominator, well, this expression here will approach the square root of 16, so 4, and this expression here is just going to approach 8 plus 2 times, and again, this expression is going to approach the square root of 16 which is just 4. Okay, so now let's simplify this here. Well, actually, right off the bat, we can just cancel out the 4. So we got negative 1 over 8 plus 8 is 60. So there we go. There's the slope of the tangent, or the rate of change of this function at x equals 5. So again, just a quick recap here. We had to use a few things. So first we had to use our methods for adding or subtracting rational expressions. Then once we did that, we had to rationalize the numerator by multiplying top and bottom by the conjugate. And then from there, we were able to simplify to solve our problem. Okay, so this had a bit of everything. Okay, that's it for this one.